%58% of Ontario's electricity is generated through nuclear power. Now, the CANDU reactors that we use in Canada, they require uranium pellets for fuel. During the processing of the uranium to make these pellets, there are many stages in which workers could be accidentally exposed to hazardous radiation. This radiation can be dangerous if it's too high in intensity or in duration. Radiation exposure needs to be kept as low as reasonably possible, which is a practice known as alarm. In keeping with this practice of worker safety, I am developing the OmniMaxBot. The OmniMaxBot is a fully self-controlled robot for use in handling of radioactive materials. So in processing uranium to make these pellets, one of the stages is called fluorination. And in this stage, the uranium passes through a flame reactor. This generates some waste in the form of uranium ash. The ash falls to the bottom of the reactor, where it's gathered into cans. When these cans get filled, they need to be replaced. Currently, the replacement step is performed by workers wearing radiation suits and driving shielded forklifts. This step actually has the highest chance for workers to be exposed to radiation. So in order to mitigate this risk, I suggest that you substitute the workers with the OmniMaxBot. The OmniMaxBot works by using a series of sensors, including laser rangefinders, inertial measurement units, and distance measurements from the wheels to determine the robot's position in a map. Using the map data, as well as software, the robot can plan a path and drive itself from its start location to wherever the empty cans are kept. The robot will pick up a can, drive it to whichever reactor has a full can. It will then swap those cans out and take the full can to a disposal location. The OmniMaxBot also has a series of ultrasonic sensors, and these are used as an emergency stop system. So if an object gets too close to the robot, it will actually stop and wait until the object leaves its area, or until an operator comes and manually drives the robot around the obstacle. Because of this, the OmniMaxBot can be used where there are workers present without running the risk of accidentally hitting the worker. Another interesting feature of the OmniMaxBot is that it uses mechanism wheels, as you can see here. Mechanism wheels are very special wheels. They allow the OmniMaxBot not just to travel forward or to turn like a car, they actually allow the robot to move to the side. This greatly increases the OmniMaxBot's maneuverability, and that's useful because there's tight spaces between the reactors that the robot needs to be able to get into. So by using the OmniMaxBot in lieu of workers for this part of the processing, we can reduce the workers' chances of being exposed to hazardous radiation and thereby decrease the risk to workers of developing harmful health effects later in life. Thank you.